Hello everyone, I'm Dr. Hussein Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. Today I'm going to explain a research article entitled as Dual Nickel Photoredox-Catalyzed Asymmetric Carbosulfonylation of Alkene. This research work was published by Cristina Novedo in 2023 in JACS. In title, dual catalysis word is used, which means in the reaction two different catalysts were used. The first one is nickel catalyst and the second one is photocatalyst. And if we look at the general reaction, this is the general reaction. In this general reaction, three different reactants were used. The first one is olefin, the second one is aryl or heteroaryl halide, and the third one is sulfonate. As three different reactants were used in this reaction, so it is a three-component reaction. It is a three-component reaction. By reacting these three different components, sulfone will be the final product, and this sulfone produced at the ratio of 99:1. And if we talk about the proposed reaction, which is also published in the same research articles, this is the proposed catalytic cycle. And in this proposed catalytic cycle, two different photocatalytic cycles were used. It is photocatalytic cycle and the second one is cross-coupling cycle, and these two catalytic cycles were interconnected with each other here. So first I will explain the photocatalytic cycle and then the cross-coupling cycle. And if we talk about the photocatalytic cycle, in this photocatalytic cycle the reaction start here. So this is the starting point for this catalytic cycle, starting point. And if we talk about the photoredox catalytic cycle, the reaction start from the photoexcitation of this photocatalyst PC. PC means photocatalyst, so I will use the term PC for photocatalyst. So the reaction start by the photoexcitation of PC by irradiation with light. So this is light source. When light falls on this PC, it will goes to the excitation or excited state. So this is the excited state of photocatalyst. When this photocatalyst goes to the exciting state, what will happen? Either this photocatalyst will accept electron from the reactant, or it will give electrons to the reactant. But in this case, this photocatalyst will accept electron from the reactant. So what is the reactant in this case? Sulfonate. So this sulfonate will give electron to the photocatalyst through single electron transfer reaction, and as a result this photocatalyst will goes to the anionic radical species, anionic radical, with production of sulfone radical. Now what will happen when this sulfone radical are produced? This sulfone or sulfonyl radical will be added across CC double bond or olefin. This is olefin or this is carbon-carbon double bond. This is sulfonyl radical. When this sulfonyl radical added across CC double bond or olefin, there are two carbon atoms. One is internal carbon and this one is terminal carbon. So sulfonyl radical either be added at this internal carbon bond and either it will be added at the terminal carbon. But if we talk about the stability of a radical, when this sulfonyl radical added to the carbon-carbon double bond, as a result, alkyl radical will be produced. Alkyl radical. And if we talk about the stability of alkyl radical, tertiary alkyl radical is much more stable than secondary, and secondary is stable than primary. So this stability will decide that the sulfonyl radical will be added to the internal carbon bond or terminal carbon bond. So in the first case, if this sulfonyl radical added to the internal carbon at this position, so it will produce primary radical. So primary radical is less stable. And if this sulfonyl radical added to the terminal carbon, so it will produce internal or secondary radical, which is much more stable than primary radical. So this stability of alkyl radical will decide that to what carbon this sulfonyl radical will be added. So this sulfonyl radical will be added to terminal carbon of carbon-carbon double bond. So as a result, this type of secondary radical will be produced, which is the reactive intermediate for this photocatalytic cycle. Now in the next step, what will happen? In the next step, this intermediate will enter into cross-coupling cycle. And when this intermediate enter into cross-coupling cycle, it will interact with nickel 0 catalyst, or this radical will be captured by this nickel catalyst, and as a result it will produce this intermediate C. And in this case, nickel goes to +1 oxidation state. And in the next step, aryl halide or heteroaryl halide, this intermediate C will be added across CX bond of aryl or heteroaryl halide oxidatively, and the nickel will goes to +3 oxidation state. And in the next step, by reductive elimination, the final product will be produced with the elimination of nickel 1 catalyst, and this nickel 1 catalyst will goes to the catalytic active species. This one is active species through single electron transfer by this photocatalyst. And when this photocatalyst transfer one of the electron to this species, so one electron will be transferred to this species via single electron transfer, and this nickel will be goes to the nickel 0. So this is all about the proposed catalytic cycle of this type of sulfonylation reaction. I hope you enjoyed the video, and if you enjoyed the video, please like and share the video, and if you are new on the channel, also subscribe my YouTube channel. Thank you.